This is Push That Rock with Simpson Math. And today we're going to look at Bayes Theorem. Think about a population. And think about a population that suffers sometimes, in rare cases, 1% of the time, from a disease. So maybe that population is teenagers. Once you become a teenager, you have a 1% chance to maybe get smart aleckiness. And so you go to the doctor, your parents take you to the doctor, and it's not that common a disease, you're not that worried about it, you really haven't shown any symptoms yet, but the parents are worried that maybe you're going to develop it. So the doctor says, well, it does affect 1% of the population. We could test for smart aleckiness in your teenage child. And so they decide to do the test, and it turns out you're positive. How worried should you be that you have this dread disease, smart aleckiness? Should you be real worried? We're going to answer that question today using something called Bayes Theorem. But you need to know that the diagnostic for these types of situations, the tool that the doctor is going to use to detect whether or not you have this terrible disease, these are not always accurate. They have sensitivity and specificity. We're going to pretend the sensitivity for the test is 99%, very accurate. That means when it's looking at a patient that has the disease, it's right 99 times out of 100. This test has a specificity of 95%. Now what that means is when it's looking at somebody that doesn't have the disease, it's right 95 times out of 100. So if 100 people walk in that don't have the disease and you give the test to all of those 100, there's going to be 95 negative results saying you don't have the disease because you don't have the disease and the test was correct. Those results are called true negatives. And there's going to be 5 results that are wrong. So they're going to be positive for smart aleckiness, even though it's not a smart alecky kid. And those are going to be called false positives. Same for sensitivity. If 100 people walk in that have the disease, 100 smart aleck kids or going to be smart aleck kids walk in, and you give them the test, 99 of them are going to be correctly diagnosed as having smart aleckiness. And those are called true positives. But there's going to be one kid where the test gets it wrong and says, no, you don't have it, even though they're born to be the worst smart aleck in the world. That negative result saying you don't have it is going to be a false negative. Okay, we've got the terminology aside. We're going to use Bayes Theorem. Bayes Theorem says that the probability of A given some information is equal to this formula. And this formula is kind of scary. In fact, it's really scary looking because finding the probability of the given event, there's a couple of ways to do it. You could, in this case, you could have the disease and get a positive result having the disease, or you could get a positive result even though you don't have the disease. You could get a positive result anyway because of those false positives. This is so bad, we're not going to use it. So, big sigh of relief, you don't need this formula. If we don't need the formula, how are we going to solve the problem? Well, we're just going to crunch the numbers a little bit. First, we'll get an approximation. So, we have the population here. It's a disease that's 1% prevalent. That means there's one person out there in the population that has it. If we give the test to that person, it's probably going to catch that person. It's 99% correct. If we give the test to the other 100 people, though, there's going to be 5 of those 100 that, well, there's only 99 others, but anyway, pretend that's 100. So there's going to be 5 where it gets it wrong. So there's going to be 5 people where it says, you have smart aleckiness. Oh, you have smart aleckiness. Oh, you have smart aleckiness. Oh, you have smart aleckiness. That's 4. There'll probably be a 5th one. The numbers are going to be about 5%. And 5% of 99 is about 5. So the parents get this positive result. and they think to themselves, OMG, I our kid's going to be a smart aleck. How are we going to get through the teenage years? But should they be so worried? What's the likelihood the child that got a positive result actually is a smart aleck? In this particular case, there's one smart aleck out of 6 positive results. That's only a 1 in 6 chance. So the chance that you're a smart aleck, given, remember this symbol means given, I probably should use the other pen. I'm sorry, Emily, my bad. The chance that you are a smart aleck, given that you got a positive test, is roughly just 1 in 6, according to Bayes Theorem. Now, we're going to be a little more precise, not that there's a big need, and you'll see that it's going to come out to be this number. The way we're going to be more precise is I'm going to create a tree diagram. I'm going to think of 100 people coming in. One of them has disease. And then 99 are healthy. I mean, they may have other problems, but they're healthy in regards to having smart aleckiness. So I've divided the population up into those that do not have the disease and those that do. When we look at this population, it's going to catch one person. Well, it's going to actually catch 0.99 people. If that's bothering you, you know what you can do? You can up these numbers. I just upped it by 2 more zeros. That means by a factor of 100. So 100, 100. Oh, okay. So I'm going to get 99 of these 100 people with the disease are positive. And these are true positives. But there's one that's negative for the disease because the test got it wrong. It's wrong 1% of the time. So this is a false negative. Now, out of these 9,900 people, it gets it right 95% of the time. It gets it wrong 5% of the time. Let's do the wrong first. That'll be easier. So let's see, what is 10% of this? 10% of this would be 990, so 5% of that will be, oh my gosh, I have to divide by 2. That'll be 445, is that right, Patty? She's supposed to yell out, yes, that's right.
No,
That's not
it
right.
goes in there 4 times, and then 9 times, and then 5 times.
Oh, okay, 495. Thank you, Patty. Okay, so 5% of 9,900 is 495. Now, these people do not have the disease, but the test got it wrong, so that means it's a positive result. It's a positive result, but that's wrong, so it's a false positive. Now, the remainder of the people, the 9,900 minus these 495, so if I back up 500 from this, I'm at 9,400. Add then the 5 back in. And these are all, the test gets it right, so they're all negatives because they didn't have the disease. And they're negative and they're true negatives. Now our question is, I have a positive result. What is the chance I'm going to be a smart aleck? Well, how many positive results are there? There's 99 here, and there's 495 here, so you put that on the bottom. So on the bottom I have 99 plus 495. Those are all of the people that I could be because I'm somebody that got a positive result. I'm the parent of a child who got a positive result, and I'm going, oh my goodness, my kid's going to be a smart aleck. But I want to know, well, how likely is it that they're a smart aleck? Well, I know they got a positive result, so I put positive results on the bottom. So that's going to give me 594 on the bottom. And now what we're going to do is figure out what goes in the numerator. Well, I got a positive result, and I want to know what's the chance I have the disease. Well, it's one of these 99 here, because these are the ones with the disease. So 99 goes in the numerator. So we have 99 out of 594 chances to be a smart aleck, even though we got a positive result from a test that's 99% accurate. And notice that that probability is roughly 1/6. And that's Bayes' theorem, ladies and gentlemen. Bayes' theorem helps you update your knowledge. So I walked in with a 1% chance to have the disease, but now I have a 1 in 6 chance to have the disease because I was given more information, namely a positive diagnostic. Success starts here at Temple College.